It is a strange and wonderful thing to consider our place in the cosmos. We find ourselves, quite improbably, conscious and aware, drifting through the velvet silence of an almost endless night. Amid the dark expanse of the cosmos, a small blue planet drifts in the quiet light of a star, one of the most common types in the galaxy, and that is Earth. It is no larger than a speck of dust when placed within the grand portrait of the universe, a mote of rock and water suspended in a sunbeam, yet Earth nonetheless holds every memory, every thought, every discovery humanity has ever known. It is the repository of our entire history. Every laugh that has ever echoed in a quiet room, every war that has scarred the landscape, every poem written in the throes of a love or despair, every invention that has pushed us forward, and every unfulfilled dream that has faded with the twilight, all of it, absolutely all of it, has unfolded on a planet just over 12,000 kilometers in diameter. When you perceive our world from the vantage point of a low Earth orbit, sensing the curvature of the horizon, our planet appears as a bright blue and white sphere veiled in layers of ever-shifting clouds, a fragile marble wrapped in the thin protective embrace of the atmosphere. But just a little farther out, say, from the distance of the Moon, over 380,000 kilometers away, this planet looks no different than a lonely pearl floating in absolute darkness. It hangs there, unsupported, a testament to the delicate balance of gravity and motion, and from even farther, from the farthest point ever captured by human instruments, about 6 billion kilometers away, Earth becomes just a faint blue dot, a single speck of light suspended in the scattered rays of the sun. That image, taken by Voyager 1 in 1990, is more than a photograph. It is a lesson in humility. It forces us to confront the reality of our situation. If we place this entire planet beside other structures in the universe, the difference in scale becomes dizzying, almost impossible to hold in the mind. Earth has a radius of approximately 6,371 kilometers, a large number in everyday human terms certainly. We perceive it as vast when we travel across oceans or fly over continents. Yet, in the language of the cosmos, it approaches zero. To visualize this, imagine Earth scaled down to the size of a coin. At that same scale, the Sun, our local star, would be a ball over a meter tall, placed about 100 meters away, the length of an entire football pitch. And in the space between these two objects, there would be nothing but darkness and silence. A vacuum so profound that it defies our terrestrial intuition. Earth orbits the Sun at a distance of roughly 150 million kilometers. That distance, known as 1 astronomical unit, serves as a standard for measuring distances within the solar system. It may seem vast, a gulf of space that takes the fastest spacecraft months to traverse, but it is merely the first step in the journey away from a geocentric view. Because the Sun, with all its light and immense power, with its raging surface and crushing core, is just one among hundreds of billions of stars in the Milky Way galaxy. And Earth itself, upon which all our maps are centered, is not the center of anything at all in the universe. We grow up with the sense that Earth is everything, the main stage, the center of existence, the point around which the heavens turn. But science, century after century, has gradually, and sometimes painfully, dismantled that illusion. Copernicus placed the Sun at the center of the planetary system, shifting our perspective from the static center to a drifting satellite. Galileo showed that Earth does not stand still, that we are in constant dizzying motion. Newton and later Einstein expanded our understanding of force, of space, of time, revealing that the stage itself is warped and dynamic, and thus the position of Earth in the universe has become increasingly diminished. That does not render human beings meaningless, far from it, but it serves as a reminder that the scale of reality far exceeds any definition the human mind can easily conceive. One of the greatest challenges in cosmological thinking does not lie in grasping equations or memorizing constants, but in accepting that human sense perception is not built to comprehend such scales. Our nervous system, evolved on the savannas of Africa to spot predators and find water, can register distances of a few hundred meters, a few kilometers, or in special cases several thousand kilometers. But when it comes to a number like 93 billion light-years, the estimated width of the observable universe, that concept slips entirely out of the realm of imagination. It ceases to be a distance and becomes a depth of mystery, a mathematical abstraction that we struggle to fill with feeling. And within that depth, Earth appears as a fragile, fleeting phenomenon, but a remarkable one, because despite its smallness, despite its physical insignificance, it is the only known place where life exists, and not just life, but knowledge. There are beings here, collections of atoms forged in the hearts of dying stars, who have looked beyond their own planet, who have recorded the light from distant galaxies, who have measured the expansion of the universe, and who have questioned the very nature of space and time. All of it from a dusty sphere orbiting a G-type star in an unremarkable corner of the galaxy. Earth's smallness does not diminish its value. It elevates the wonder of existence. Because within a seemingly indifferent universe, in a nearly nameless place, there is consciousness. There is the ability of the universe to look back upon itself through spacecraft images, through massive telescopes, and through late-night contemplations about existence, death, and the infinite. The question is no longer how big Earth is, but whether its smallness can contain vast dreams, whether human awareness can transcend the boundaries of this planet and become an organic part of the universe, or whether Earth, with all its history and longing, will be but a solitary echo in the silence of space. In the perception of the cosmos, Earth is not special because it is large. It is special because from that place there are minds that have begun to look far, and in that very act of looking, through not just the instruments but the intellect, humanity reaches beyond itself. And if one day the light from Earth quietly fades into the cosmic tapestry, there will still remain this one truth, that a small planet once dared to look up and once asked the question of what it meant to exist in the midst of the infinite. If Earth is a speck of dust in the desert of the cosmos, then the sun is the colossal flame around which an entire world revolves. Every planet, every moon, every comet and asteroid in the solar system moves according to the gravitational fields generated by the sun. Without its light and energy, Earth would become a frozen, lifeless mass, a rock drifting in the void, and without its gravitational pull, the entire planetary system would unravel like a flock of birds scattered in a storm. In this universe, the sun is not merely a ball of fire, it is the centre, the heart, the conductor keeping time for an ancient celestial dance. The diameter of the sun is approximately 1.39 million kilometres, about 109 times that of Earth. But the real disparity lies not in length, but in volume. If we used Earth as a unit of measurement, more than 1 million Earths could fit inside the sun. While such figures may seem dry, simply imagining 1 million blue marbles tucked within a glowing sphere renders the concept of large nearly meaningless in ordinary terms. The sun is composed primarily of hydrogen and helium, the two simplest and most abundant elements in the universe. But from these components, under unimaginable pressure and temperature in its core, a process of nuclear fusion takes place. It is a process of transmutation, of alchemy on a cosmic scale. Every passing second, about 600 million tons of hydrogen are converted into helium, generating an immense amount of energy, equivalent to hundreds of millions of times the total human energy output in the same period. Most of that energy radiates outward as electromagnetic radiation, of which only a small fraction is visible light, and only a tiny portion of that fraction reaches Earth after a journey of 150 million kilometres. Yet, even that is enough to warm the oceans, illuminate the skies, stabilise the climate and sustain all life on the blue planet. The time it takes for light to travel from the sun's core to its surface is not a matter of seconds but hundreds of thousands of years. Photons born in the core, in that crushing inferno, are scattered millions of times in the dense plasma interaction zone, bouncing chaotically like a ball in a pinball machine before they finally escape and shoot into space. Once they pass the sun's surface, however, that light takes just over 8 minutes to reach Earth. This means the sunlight touching your skin today is the result of a nuclear reaction that began in a distant past when humanity had yet to invent writing and civilization had no name. It connects us to deep time. But the sun is not an eternal flame. It has been alive for about 4.6 billion years and is currently in the middle of its life cycle, a middle-aged star on the main sequence. When the hydrogen in its core is depleted, when the fuel that sustains it runs dry, this star will gradually expand into a red giant, large enough to engulf Mercury, Venus, and possibly Earth. The oceans will boil, the atmosphere will be stripped away, and the cradle of life will be consumed by its parent. After that, it will shed its outer layers, creating a beautiful planetary nebula, leaving behind a hot, dense core, a white dwarf quietly cooling over trillions of years. Any remaining planets, if there are any, will drift in silence around a remnant that no longer shines with the vigour of its youth. From a galactic perspective, the Sun is merely a G2V-type star, a yellow dwarf, neither rare nor remarkable, not too big nor too small. Among the hundreds of billions of stars in the Milky Way, countless others are similar or vastly larger. But it is precisely this stability, this ordinariness, that allowed Earth to exist. The Sun does not explode without warning, does not oscillate violently, nor does it fluctuate its intensity erratically. It is a steady, enduring light in the darkness, offering the ideal conditions for life to evolve over billions of years. The energy from the Sun is not just heat and light, it also carries charged particles forming the solar wind, streaming into space at millions of kilometers per hour. When these particles encounter Earth's magnetic field, they create the spectacular auroras at the poles, ribbons of green, purple and red light swirling like a cosmic dance at the edge of the sky. Yet, the same energetic flows, when erupting too strongly as solar storms, can disable satellites, disrupt GPS signals, and affect global power grids. This Sun, therefore, is not only a source of life, it is also a source of risk. A world can be bathed in light or plunged into chaos depending on the rhythm of that blazing heart. And although humanity today can measure radiation, forecast sunspot activity, or plan spacecraft missions based on physical models, in the end, we are still creatures trying to read the pulse of a star we cannot control. In art, the Sun has been painted as a god, a deity riding a chariot across the sky. In religion, it is a symbol of light, life, and resurrection. In science, it is a power plant, a colossal fusion reactor held together by its own gravity. But perhaps above all, the Sun is a reminder that behind every warm day, every glimmer on the ocean, every dawn that begins anew, is the result of a chain of reactions unfolding silently from a place far beyond the reach of imagination. If there is one reason the Sun holds the centre, it is not merely because of its gravity, but because from its light life emerged, awareness developed, and humanity began to ask questions about its place in the universe. It is thanks to that ceaseless fire that we are able to look outward and ultimately look inward. The Sun, though it plays the central role in our planetary system, is far from the upper limit of cosmic size. When we extend our gaze beyond the solar system, reality begins to defy belief. There are stars not only larger than the Sun, but so immense that the Sun itself would appear as a dim speck beside them. This is the realm of giants, where numbers become surreal and human imagination is forced to bow before reality. One of the first names to step into that realm of the unimaginable is Betelgeuse, a bright red star resting on the left shoulder of the Orion constellation. It lies about 640 light-years from Earth. Even at that distance, it remains visible to the naked eye on clear nights, a distinct ruddy point of light. What is astonishing is this. If Betelgeuse were placed at the centre of our solar system, its surface would extend all the way to the orbit of Mars, perhaps even beyond. Its diameter is about 1,000 times greater than that of the Sun, and its volume could contain hundreds of millions of suns. This is no longer a mere difference in size. It is a qualitative leap in how the structure of the universe must be understood. Betelgeuse is a red supergiant, a star nearing the end of its life, swelling as the fuel in its core runs low. Inside it, nuclear fusion reactions are forging heavier elements from carbon and oxygen to even iron. When it reaches its limit, when it can no longer sustain the pressure against gravity, the star will collapse inward in a supernova explosion, an event capable of outshining an entire galaxy by billions of times. Life on Earth will remain unaffected due to the distance, but if this happens in our era, the night sky will gain a second moon, steady, blood red, and lasting for weeks before it fades. But Betelgeuse is not the ultimate. There are stars even larger. Mu Cepae, also known as the Garnet Star for its deep crimson hue, is a prime candidate for one of the largest known stars. Its exact distance from Earth remains uncertain, but its estimated size far exceeds that of Betelgeuse. And rising above them all, at one point, V1 Canis Majoris was believed to be the largest known star, with a diameter potentially over 1,500 times that of the Sun. If placed at the centre of our solar system, its outer layers would reach the orbit of Saturn. That means not only Mercury, Venus, Earth, and Mars would vanish within it, but even Jupiter would be swallowed whole. At such scales, comparison becomes absurd. If the Sun were a rubber ball placed at the centre of a stadium, Betelgeuse would be a colossal hot air balloon hovering above, eclipsing the stadium dome. V Canis Majoris, by contrast, would be a flaming world engulfing the stands, surrounding roads, and dozens of neighbouring city blocks. Imagination, no matter how persistent, cannot fully recreate the feeling of standing before such a star. What's even more astonishing is the density of these enormous stars. Though their size exceeds the Sun by millions of times, their mass is usually only several to a few dozen times greater. This means their internal matter is incredibly diffuse. If you could fly through the outer atmosphere of Betelgeuse, you wouldn't encounter a dense wall of flame but a light, tenuous sea of plasma where atoms rarely collide. These are not compact giants. They are luminous phantoms of the cosmos. So why do such enormous stars exist? The answer lies in their initial mass at formation. When a gas and dust cloud large enough collapses under gravity, it creates the pressure and heat necessary to ignite nuclear fusion. If the mass is high enough, fusion doesn't stop at hydrogen, but proceeds to produce heavier elements. It is the delicate balance between the outward push of nuclear fusion and the inward pull of gravity that determines the shape, lifespan, and fate of a star. Giant stars live fast and die young. While the Sun's life expectancy is about 10 billion years, Betelgeuse may only last a few million. But in that fleeting lifetime, they create the very elements necessary for life. Carbon for organic structures, oxygen for water, iron for blood. And when they explode in a supernova, those elements are released into space, mixing with other gas clouds, seeding the next generation of stars, planets, and life. We are therefore not merely distant observers of these stars, we are their descendants. The iron in our blood, the calcium in our bones, the carbon in our cells, all were once remnants of a dead star. This is a profound connection. When we look up at the night sky, we do not merely see light. We are looking at our origin. Betelgeuse, Mu Cepae, VY Canis Majoris. These strange names belong to blazing entities lying hundreds or even thousands of light years away. They are witnesses to a universe unfolding on scales beyond human comprehension. Every star is a story, every light is a memory. And each time we look at the sky, we're reminded that greatness does not lie in what we can touch, but in what forces the mind to fall silent in awe. Amidst the myriad of lights flowing across the night sky, there are stars that not only shine but blur our everyday notions of big. VY Canis Majoris is one of them, a red hypergiant star located about 3,900 light-years from Earth, hidden in the constellation Canis Major, Latin for the Great Dog. But that name fails to capture the true scale of this star. If placed at the position of the Sun, its surface would extend all the way to Saturn's orbit. Imagine that for a moment. A single object so vast that light itself takes hours to circle it. When it comes to the size of VY Canis Majoris, ordinary comparisons become useless. Its estimated diameter is over 1,400 times that of the Sun. The mass of just the gaseous shell it is ejecting into space already exceeds the combined mass of hundreds of Earth-sized planets. If the Sun were a ball set at the centre of a stadium, then VY Canis Majoris would be the entire stadium spilling into the stands, covering the surrounding city glowing faintly from within a red mist. It is not merely a star, it is a colossal structure of light dying in the dark. V Canis Majoris is not as stable as the Sun. It is in the final stage of a star's life, a phase where massive layers of gas expand and contract like a cosmic creature breathing with difficulty. This star is steadily losing material, ejecting hot gases at hundreds of thousands of kilometers per hour. Each breath is a loss, each pulse a warning that the end is near. Although its light takes millennia to reach human observers, at its location, time is running out. What makes VY Canis Majoris extraordinary is not only its size but the fragility within that size. Despite its enormity, its density is extremely low. The outer layers of this star are so light that if a hypothetical spacecraft could fly through them, it wouldn't encounter a thick wall of plasma, but rather an ocean of mist where particles float in an almost weightless state. A giant made of light, yet so hollow it is nearly transparent. From an astrophysical perspective, VY Canis Majoris is a lesson on the ultimate limits of stellar stability. When mass and pressure can no longer balance gravitational force, the star begins to unravel. In the case of red hypergiants like this, death does not come instantly. It stretches out slow, volatile, like a final symphony echoing through silent space. And when the collapse arrives, VY Canis Majoris may explode as a Type II supernova, or perhaps even as a hypernova, powerful enough to form a massive black hole where space and time are entirely warped. But even before the explosion, this star has played a vital role in the universe. From deep within it, over millions of years, heavy elements are being forged. The building blocks of planets, of life, of the human body itself. From the calcium in our bones to the iron in our blood, all could have originated from nuclear reactions in the core of light monsters like VY Canis Majoris. It is not merely burning, it is crafting matter for future worlds. If VY Canis Majoris were visible to the naked eye, it would dominate the sky, but it is obscured by distance and cosmic dust. We can only detect its presence through infrared and radio wavelengths, through images captured by space telescopes like Hubble and Spitzer. And when those data become images, we don't see a spherical ball of fire, but a bizarre asymmetric form, as though the universe were trying to conceal something too vast to reveal fully. The beauty of VY Canis Majoris does not lie in perfection. It lies in impending disintegration, in glorious imperfection. When standing before such a star, the question is not how big it is, but why something so fragile could hold its shape long enough for its light to reach us. And that hints at a deeper reality. The universe is not merely a place of precise operation, but a place where boundaries are collapsing in silence. Now, consider this. In the world of planets, stars, galaxies, and cosmic superclusters, humanity encounters a special kind of limit, a boundary not born of missing information, but of the architecture of the mind itself. When numbers exceed what we can sense, when length, volume, or mass stretch beyond every lived experience, language begins to fracture, comparisons become useless, and imagination is forced to surrender before reality. Imagine shrinking the entire solar system down to the size of a coin. At that scale, the Milky Way would span the entire continent of North America. Earth in that image is negligible, not merely small, but completely invisible. And everything humanity has ever done, thought, or written has taken place on a point that cannot even be located on a coin, placed somewhere within an imagined continent. Imagination evolved to ensure survival. It developed to help our ancestors hunt, navigate, and avoid danger. It can sense a herd of deer from 100 meters away, or detect a storm approaching from the horizon. But it was not made to comprehend the mass of a neutron star where a teaspoon of matter weighs as much as Mount Everest. It was not built to handle numbers like 93 billion light-years. At that level, the mind requires another tool, a bridge between number and feeling, between data and intuition, and that is the role of awe. When imagination breaks down, awe enters, not to replace logical thought, but to guide a different kind of understanding, one that doesn't need explanation, only quiet acceptance. Like standing before the ocean for the first time or seeing a snow-capped peak in morning mist. Vastness does not need to be understood, only felt. The true scale of the universe doesn't merely make us small. It lightens what once seemed central. A personal sorrow, a conflict, a worry about status, wealth, or power all fade into the background when faced with the number 100 billion galaxies. And yet smallness also brings depth, because within that infinite expanse there is one tiny point that knows it is small. There exists a form of life capable of looking up and asking, what does this mean? When imagination fails to keep pace with actual scale, the universe does not become less real, it simply becomes quieter. And in that quiet, a silent dialogue begins, not a conversation between people, but between life and the whole. As we move beyond our own galaxy and observe the neighbouring ones, a broader picture begins to unfold. Galaxies are not scattered randomly. They do not drift alone like islands in a desolate ocean. Instead, they cluster into groups. Groups gather into clusters, and clusters assemble into superclusters. Seen from afar, the universe resembles a colossal web, a sophisticated structure where threads woven from galaxies connect to form configurations beyond imagination. And within that structure, the Milky Way, our galaxy, is but a very small part of a supercluster named the Virgo supercluster. The Virgo supercluster is the first large-scale cosmic structure humanity ever identified. It is not simply a collection of nearby galaxies, but a region of space spanning roughly 110 million light-years, where tens of thousands of galaxies are organized into a cohesive system under the influence of gravity. Within it, the local group, including the Milky Way, Andromeda, and their satellite galaxies, is merely a peripheral branch, a small cluster on the outskirts. At the center of the Virgo supercluster lies the Virgo cluster, a densely packed region of thousands of galaxies, so concentrated it feels breathless. The Virgo cluster is about 65 million light-years away. If Earth were to send a beam of light there, it would arrive around the time the dinosaurs went extinct. This means when we observe light from the Virgo cluster's galaxies, we are witnessing a distant past, a slice of the universe when life on Earth was still in its infancy. But it is precisely through such slices that we begin to perceive a pattern. Galaxies not only exist but follow order, and architecture is beginning to reveal itself. As astronomers extend their view beyond the local group, they notice that galaxy clusters are distributed according to a structured pattern. They do not fill space uniformly, but instead form elongated threads called filaments and vast empty expanses called voids. The Virgo supercluster is one of these dense threads linking galaxy clusters, like the backbone of an unnamed cosmic organism. Seen from afar, the entire universe takes the shape of a giant web, a cosmic web, where matter is not randomly dispersed but arranged into concentrations like intersections on a hyperscaled map. It is here that the concept of a cosmic address becomes clearer. We do not simply live on Earth within the solar system in the Milky Way, part of the local group, but also within a much larger region, a galactic district called the Virgo supercluster. This adds a new layer of meaning where space is no longer a disconnected scattering of lonely lights, but a deliberate architecture, an organized framework that hints at a silent design. The Virgo supercluster is not only magnificent in size, but also in its physical harmony. The galaxy clusters within this supercluster do not merely exist in proximity, but are being drawn toward a common gravitational center. From the Milky Way's position, we are moving toward the Virgo cluster at a velocity of roughly 600 kilometers per second. A cosmic pilgrimage is underway, silent, unannounced, spanning hundreds of millions of years. And this raises a scientific question. If we are being pulled toward a destination, what force lies there? What occupies the center hidden behind hundreds of millions of light years? It is from questions like these that the idea of cosmic architecture ceases to be an abstract theory. It becomes a map locating humanity within the universe. If the Milky Way is a house, then the Virgo supercluster is a city. And like any great city, it has districts, a center, suburbs, and arteries of movement. But none of it built by human hands. Instead, it was formed through the fundamental laws of physics: gravity, dark matter, dark energy, and time. Yet what matters is not just the existence of the Virgo supercluster, but what it evokes: that the universe is not chaos. Though born of turbulent expansion following the Big Bang, the universe has formed structure. This suggests that from disorder, order can arise. From turbulence, architecture can emerge. And if the universe can do this on its larger scales, then human consciousness, a product of the universe, also holds the potential to mirror that structure in thought, in science, in art. The Virgo supercluster is a midpoint in a much grander picture. It is not the ultimate limit. Today, astronomers know that it is part of an even larger structure, Laniakea, a supercluster containing roughly 100,000 galaxies and stretching over 500 million light-years. Within Laniakea, Virgo is just a stream within the river of galaxies, and the local group, with all that we know, is merely a drop in the cosmic ocean. But to reach that realization, we must begin with Virgo. From the first observations of galaxy clusters tens of millions of light-years away, humanity first understood that we're not at the center of everything, that a larger, more beautiful, more intricate picture awaits discovery. And in that picture, we are not lost. We have an address, a place, a pathway marked by light. The Virgo supercluster is more than a cluster of galaxies. It is a threshold, a bridge between the familiar and the vast. It is where we realize that the universe is not only immense but layered, organized, and deep. And within that structure, life, no matter how small, has its place. A location inscribed in the map of light, in the music of motion, and in the awareness that dares to ask, how did the universe from nothingness build such an architecture? There are moments in the history of human awareness when the veil of the universe suddenly lifts, and we realize that everything we thought we knew is just a small part of something far greater. Laniakea is one of those moments. No longer merely a galaxy cluster, nor even a supercluster like Virgo, Laniakea represents a radical expansion in the way we locate ourselves in the cosmos. It doesn't just show how vast the universe is, but reveals how galaxies are connected, drawn, and moving as if drifting along the current of an invisible cosmic river. Laniakea in Hawaiian means immeasurable heaven, and that name is not merely poetic, it is a precise description of the grand structure we have only recently discovered. Laniakea is a galactic superstructure encompassing around 100,000 galaxies stretching over 500 million light-years. Within it lie the Virgo supercluster, the local group, the Milky Way, and the entire night sky ever visible to the human eye. This means every star you have ever seen, every galaxy ever captured by a telescope, is only a small part of the massive flow called Laniakea. To imagine this, picture the universe as a bottomless ocean where matter does not remain static, but flows along gravitational currents. Just as water is carried by tides, galaxies are drawn by invisible streams not shaped by surface features, but by the distribution of mass across space. Laniakea is not a solid block. It is a flow field where galaxy clusters move toward a shared gravitational center, as if being pulled into a nameless core. The method of discovering Laniakea is also a triumph of human intellect. Instead of simply observing galaxy positions, scientists measured their velocities relative to the cosmic microwave background. By subtracting the motion due to universal expansion, what remains is their intrinsic motion. That is the direction each galaxy is truly being pulled toward. From this, a map of velocity vectors was constructed, and just as water flow outlines the shape of a river, these motion vectors reveal the boundaries of Laniakea, a gravitational map not marked by hard edges but full of physical meaning. In that picture, the Milky Way is only a tiny offshoot. The flow of motion our galaxy follows does not head toward the Virgo supercluster, as once thought, but toward a point known as the Great Attractor, a region of space containing an enormous mass silently drawing all of Laniakea toward it. We don't know exactly what lies there. It is obscured by the plane of the Milky Way, where dense dust and stars block light from passing through. But gravity remains, and our galaxy, along with hundreds of thousands of others, is being pulled toward that invisible point, as if the entire surrounding universe is falling into a cosmic abyss yet unnamed. The existence of Laniakea radically changes our understanding of cosmic structure. No longer are galaxy clusters floating aimlessly through space, but intricately connected networks bound by gravity, by shared formation histories, by flows far larger than any single galaxy. This compels us to confront a simple yet profound truth. Galaxies do not exist independently. The Milky Way is not drifting in isolation. It is a part of a larger current bound to galaxies hundreds of millions of light years away, like water molecules within the same stream. And within that awareness, our existence becomes both fragile and magnificent. Fragile because we do not control the trajectory of even our own galaxy. Everything is drifting, being drawn, moving according to macro forces that no civilization, no matter how advanced, can reverse. Yet magnificent because within this cosmic flow, a form of life has arisen with the capacity to look back upon the very flow it travels, to name it, to understand it, and to exclaim, "We are part of Laniakea." The ability to perceive cosmic architecture is not just a scientific milestone, it is a leap in consciousness. For when we realize that our galaxy is merely a streamlet in a much greater river, we begin to understand that all the divisions humankind has ever constructed, national borders, personal identities, religious frames, dissolve in the cosmic view. All are residents of a shared current, and if all galaxies are moving toward the same destination, then perhaps life, if it exists elsewhere, is also being drawn to the same center, not only in space, but in consciousness. Laniakea, in a sense, is not a place. It is a journey, an orbit, a deep motion across time and space. And in naming it, we acknowledge that connection is not a choice. It is a physical truth. We are born in a drifting galaxy within a drifting cluster, inside a network gradually taking shape, and where we are heading remains a mystery still unnamed. But it is that very movement which makes all stories possible. All light emitted, all consciousness emerged. Laniakea is not an endpoint. It is an invitation, a map drawn from gravity, from ancient light, from motion hidden in darkness. And if we follow that flow to its end, we may not only find other galaxies, but find ourselves in a cosmic structure that has bound all things together since the beginning, not with strings, but through existence itself. There is a strange moment when looking deep into the universe and realizing that the image reflects something inside the mind. A map of galaxies connected by gravitational threads bears an uncanny resemblance to a cross-sectional scan of the human brain. The bright spots are galaxy clusters, the connecting strands are cosmic filaments, and the voids are silent zones like black holes where no signal, no light reaches. When two entities separated by billions of light years share the same geometric structure, questions begin to arise. Is the universe thinking? Or conversely, is consciousness a miniature replica of the cosmos? The cosmic web is one of the most astonishing discoveries in modern astronomy. Though invisible to the naked eye, by combining data from millions of galaxies, cosmic microwave background maps, and the largest physics simulations ever conducted, a structure begins to emerge. The universe is not a random clump of matter, but a vast network where matter is arranged in strands, nodes, and voids like a kind of cosmic nervous system. This structure formed very early when the universe was just a few 100,000 years old. Minute fluctuations in matter density known as quantum perturbations were amplified by cosmic expansion and gravity. Matter began to cluster in regions with slightly higher density than average. Gradually, gas and dust clouds formed stars, galaxies, and galaxy clusters. But strikingly, these dense regions are not isolated. They are connected by streams of matter, filaments, and the entire system stretches across space like a three-dimensional web. On the largest scale, the universe is not uniform. It resembles a network more than a flat carpet, and that is what makes it uncannily similar to the structure of the human brain. Scientists have compared supercomputer simulations of the cosmic web with images of neural connectivity in the brain. Despite differences of many orders of magnitude, billions of light years versus millimeters, the connectivity ratios, distribution patterns, and interaction modes of nodes are strikingly alike. In the human brain, each neuron does not exist in isolation, but connects to thousands of others through axons and synapses. In the cosmic web, each galaxy cluster is not adrift alone, but linked to many others through filaments of dark matter, invisible threads with immense gravitational pull. Both systems, brain and universe, are optimized for information transmission, energy distribution, and survival in a constrained environment. This similarity is more than a visual coincidence. It opens a new dimension of reflection. If the brain is where consciousness arises, could the cosmic web be a form of superconsciousness? If the human brain operates via electrical currents and chemical impulses, the cosmic web functions through gravity and dark energy. One processes thought, the other expansion, but both seem to have a purpose: to arrange information in meaningful order. In physics, there is a curious principle called geometric analogy. It shows that vastly different systems in terms of matter and energy can still share the same mathematical structure, like fractal geometry or small world networks. This means that regardless of internal composition, as long as the rules of connection are similar, the resulting structure will be the same. The human brain and the universe may differ in essence, but if they follow the same organizing principles, they will resemble each other geometrically. But why is this so? Why does the universe, born of a purposeless primordial explosion, self-organize into a structured web? And why does that structure mirror the very organ that creates awareness? Some suggest this is a form of reflection, that consciousness is the universe observing itself, that the brain is a miniature version of the whole. Just as a drop of water reflects the entire ocean, a single brain echoes the connective form of the universe from which it emerged. The cosmic web is not just a physical phenomenon, it hints at a deeper level of connection. In a universe where every galaxy is linked by dark matter strands, isolation is an illusion. And if dark matter is what holds this entire structure together, though we cannot see it, then it is no different from subconscious thoughts, always present, shaping behavior, yet inaccessible directly. And one more thing, if this entire network is changing, evolving, then the universe is not static. It resembles a living organism that is learning, expanding, accumulating information. In the human brain, the formation of new connections underpins learning. In the universe, the creation of new filaments results from gravitational evolution. Is this merely metaphor, or is the universe truly learning? That question remains unanswered. But when placing an image of the cosmic web beside a neuron scan and finding them indistinguishable without labels, something stirs. Not just in appearance, but in feeling the sense that the outer and the inner are no longer separate. That when gazing at the night sky, one is not only looking outward, but inward into a cosmic brain of which we are a small part. A tiny spark situated somewhere along a filament among hundreds of billions of stars trying to make sense of the whole. And perhaps that is the true function of consciousness, to connect the luminous points into a network of meaning. The universe is not merely a collection of isolated stars. It is not a desert of scattered light arranged at random. It is a structure where each galaxy cluster is a massive island, and between them lie invisible threads woven together into the greatest network ever to exist. Scientists call them filaments, vast strands of matter stretching hundreds of millions of light years, functioning as the cosmic spines. They don't merely connect superclusters of galaxies. They operate as the primary framework of spatial architecture. And within that structure, the idea of connection in the cosmos reaches its most profound expression. Each supercluster, such as Virgo or Laniakea, does not drift alone. They lie on gravitational pathways linked together by dark matter and diffuse gas. Seen from afar, superclusters resemble junctions on a colossal map, and filaments are the cosmic highways threading through space. Some filaments stretch up to 500 million light years, meaning it would take light 500 million years to traverse the length of one strand. In that time, life on Earth could evolve from single-celled organisms to humans. Yet on a cosmic scale, that is merely a single vibration. Filaments are not radiant like galaxies. They do not shine. Most of what they are composed of is dark matter, a type of matter that neither emits nor absorbs light, yet accounts for the majority of the universe's mass. It is dark matter that generates the gravitational pull, shaping the filaments. Silently, it draws in ordinary matter, hydrogen gas, cosmic dust, isolated stars, gathering them along invisible streams, forming long connective threads akin to a backbone. These strands are the relics of an early epoch when the universe was still rapidly expanding after the Big Bang. In recent years, thanks to next-generation telescopes and advanced spectral analysis, astronomers have begun to observe hydrogen gas filaments between superclusters. One of the most spectacular discoveries is the filament connecting the Perseus Pisces supercluster with the Coma supercluster. Massive streams of gas, faint but immense, link two superclusters separated by hundreds of millions of light years, like a suspension bridge spanning the cosmos. These gas flows are not just connective tissue but migration pathways for galaxies, where gravity channels cosmic constituents from one region to another, like circulating blood in a living organism. Filament structures are not uniform. Some areas are dense, others sparse. Certain sections twist into knots, birthing new galaxy clusters. Others stretch toward the cosmic fringe, connecting to voids, regions nearly devoid of galaxies. This makes the cosmic web resemble a dynamic model, not fixed but constantly evolving with time. And if the filaments are the cables through which gravity flows, then voids are rest stops, spaces where oscillations subside before giving way to a new current. But the most remarkable aspect is this. There is no clear boundary between filaments and superclusters. No defined beginning, no distinct end. They interlink, flow through one another, forming a fractal pattern where every small part reflects the structure of the whole. A single filament segment may contain dozens of galaxy clusters. A junction between filaments might become the birthplace of a new supercluster in the next few billion years, and each secondary branch could drag along the destinies of billions of stars. This raises a question tinged with philosophy. If the universe is interconnected by such filaments, then might every galaxy and every civilization also be bound by a common current? If life exists elsewhere, is it too being drawn along the same filament heading toward the largest gravitational centers? And if so, could it be that one day these civilizations will encounter one another, not by chance, but because they have long shared the same drift? Filaments do more than link galaxies. They suggest that the universe is an organized entity. In plasma physics experiments and atmospheric simulations, filaments also emerge when energy and matter reorganize to enable efficient flow. This could mean where there is flow, there is structure, and where there is structure, there is logic, a form of spontaneous order arising from chaos. The universe needs no directing hand, yet it forms a framework that feels intentional. Filaments are the silent signature of cosmic evolution, and within that entire network, the Milky Way is but a speck, a tiny junction lying along a distant filament at the outer edge of Laniakea. But no matter how small, our galaxy still rests on a thread, connected and drifting like neurons in the brain. Each node in the cosmic web is a potential point of consciousness, a luminous dot that may flare into awareness. And if the universe truly has the capacity to think, then filaments are the channels through which its thoughts travel. Not all things are visible in light, not every connection is sharply defined. But filaments, the threads between superclusters, are evidence that the universe is not static, not fragmented, not chaotic. It is a vast living network breathing, flowing and shaping its form, and within every filament lies a message that everything, everywhere is connected, not just by matter, but by the very meaning of existence. Each time the eye looks up at the night sky, light from millions of light years away touches the retina silently, patiently, as if the universe is recounting its story through each quiet photon. But there is a limit. Not because our lenses are too small or our detectors too insensitive, but because the universe, no matter how vast, has a horizon, a boundary beyond which light has never had the chance to reach us. The observable universe is not the entirety of the cosmos, but only the part humanity can access through sight. And that boundary is the very horizon of human perception. The observable universe has a radius of about 46.5 billion light-years from Earth, meaning a diameter of approximately 93 billion light-years. Though the universe is only about 13.8 billion years old, the constant expansion of space has stretched regions that were once close to us to immense distances. Light from the early universe, emitted over 13 billion years ago, has travelled through ever-expanding space to arrive at the human eye today. Thus, what we see are images of the past from points that were once nearer, but are now at the edge of the cosmic horizon. This cosmic horizon is not a physical wall, it has no clear boundary. It is not a curtain hiding something definite, rather it is an information limit, a curvature of time and space where light has yet to arrive. Like standing atop a mountain and looking out to sea, the horizon is not the edge of the ocean, but simply the farthest point the eye can see. Beyond it, the sea continues, and so it is with the universe. Beyond the horizon, the cosmos persists, but we cannot yet know it. Everything humanity has ever discovered, from nearby galaxies to the ancient cosmic microwave background, lies within this massive sphere. And the remarkable thing is we are always at the centre, not because Earth is special, but because the observable universe is always drawn from the viewpoint of the observer. If you stood in another galaxy, you would see a similar sphere with yourself at the centre. This is not a sign of arrogance, but a fundamental property of a homogeneous universe. Every point can serve as the centre of its own observable cosmos, but the true universe may be far larger, perhaps infinite. Some theories suggest that beyond the observable universe lie regions where light has not yet had time to arrive. And if space is indeed infinite, there may be infinite galaxies, infinite stars, and even infinite versions of ourselves existing somewhere unfathomably far, repeating every decision, every event in a quantum game we can never witness. These ideas not only stretch space, but also blur the line between science and philosophy. The observable universe is a mirror reflecting limitation. A limitation not only of technology, but of time, light, and the transmission of information itself. Every telescope, be it as powerful as James Webb or as immense as the SKA, is aimed at the same goal: to push that horizon outward, to find the first light, to capture faint signals from the moments closest to the Big Bang. And each time we do, the boundary of what is known expands, even though the actual universe always remains out of reach. Within that boundary, the strange truth is everything we see is drifting. Every galaxy, every distant structure is moving away, carried by the expansion of space itself. And when that velocity exceeds the speed of light, a result of space expanding fast enough, those galaxies vanish forever from view. Not because their light is absorbed, but because the space between us and them stretches endlessly, preventing the signal from ever arriving. It is a death in silence, a farewell without words. For this reason, the observable universe is not just a map of locations, but a diagram of time. To look far is to look back through history. A galaxy 10 billion light-years away is a galaxy 10 billion years old, meaning it existed long before Earth was formed. In this sense, the observable universe is a living museum of the cosmos, a library of light where each page is a frozen galaxy suspended in time. And yet within those limits, something miraculous occurs humans can understand. We can calculate distances, estimate the age of the universe, reconstruct its evolution through Einstein's equations, through the cosmic microwave background, through the distribution of galaxies. Using the tools of science, human awareness, a fragile phenomenon on a small planet, has expanded to the edges of time and space. The observable universe, therefore, is not just a boundary of light, but a boundary of intellect. Every step forward in science is a shift in the horizon, but that horizon will always remain not as a final limit, but as an invitation to keep exploring, to keep observing, to keep imagining. For beyond the visible region, the unknown still unfolds, and that void, the space where light has never touched, is precisely where the most beautiful questions arise. Questions of origin, of structure, and of the role of consciousness in a universe without end. The observable universe is a painting. Humanity is still composing with light, with data, and with unquenchable curiosity. And the edge of that canvas, though always shifting, always reminds us each time we look farther, we also understand more deeply who we are. Because light, even from the farthest reaches of the cosmos, always ends its journey in a mind that dares to ask, where are we in all of this? In the primordial darkness of the early universe, there was a miraculous moment when the first light appeared. Not from a sun, not from a star, but from the very release of radiation when matter and light separated, allowing the universe to become transparent. This was the moment when light was first permitted to travel freely, no longer continually absorbed by the dense plasma as before. And from that moment on, the universe began to keep memory through those very first photons that escaped, carrying information about the origin of everything. That moment occurred about 380,000 years after the Big Bang. By then, the universe had cooled enough for protons and electrons to combine into neutral hydrogen atoms. At that point, there were no more free charge particles to obstruct light. Photons began to move freely and the universe became transparent. The signal from that moment still exists today in the form of the cosmic microwave background, CMB. It is the oldest light humanity has ever seen, and it is not just light. It is the universe's first map, a map of primordial fluctuations, the precursors to every galaxy, star, and planet. James Webb and other modern space telescopes are all striving to peer back through time to get as close as possible to that starting point. But the light of the first stars, known as Population 3, arrived even later. The first stars formed a few 100 million years after the Big Bang. They were massive, blazing hot, and very short-lived. Yet, it was their light that first pierced the cosmic night, ending the period known as the Dark Ages, the time when the universe existed, but no visible light had yet appeared. From that point on, the light from the earlier stars and galaxies began to fill space. Those small, faint lamps over billions of years became the brilliant forests of stars we see today. But because the speed of light is finite, the further we look, the further back in time we see. Each layer of light captured by a telescope is a layer of history, a cross-section of time. The deeper we probe, the closer we get to that first light. The observable horizon is the farthest limit light has been able to reach us. Not because light is not fast enough, but because there has not been enough time. The universe is only 13.8 billion years old, so light has only been able to travel that long. Yet because of the expansion of space, regions that emitted light very early on are now over 46 billion light-years away from us. And this creates a strange paradox. The points closest to the Big Bang are the most distant on the map of the observable universe. When we speak of the edge of observation, it is not just a spatial limit, but a limit of knowledge, because every cosmological theory must be tested by data, and that data can never come from beyond the boundary. This means that what lies beyond the first light will always remain unknown. No signals, no way to reach it, only hypothesis. And here is where science brushes the edge of philosophy, where questions become less quantitative and more ontological. Does outside the universe mean within something larger, or is it simply nothing? This is akin to asking what is outside of space, or what was before time, questions that ordinary language is not equipped to express. If space is all that exists, then the notion of outside becomes meaningless, just as a fish cannot conceive of water as an environment, for it is the very condition of its existence. Human thought, constrained by notions of inside and outside, tries to impose those frameworks on a reality that may be entirely beyond form. What lies beyond the observable universe may never have a definite answer, but what matters is that the very question expands our awareness. It draws the human mind beyond the circle of comfort where everything must be seen, measured, verified. It forces us to accept the humility of knowledge, that some limits cannot be crossed with instruments alone, but only with intuition, and the courage to accept that truth may always be greater than understanding. Perhaps what lies beyond the observable universe is not meant to be seen, but to ensure that the journey of awareness never ends. A permanent blind spot, like the horizon that always recedes as we approach, is what keeps humanity forever in a state of learning. Not because we will one day see it all, but because each step closer reveals a deeper layer of truth. And in that way, the space beyond the boundary is not merely a region, it is a symbol of the unknown, of the boundless potential of consciousness, of the truth that not everything must be seen to be believed. Sometimes it is the very thing we cannot see that nourishes our hunger for understanding. The same hunger that has taken humanity from the flicker of fire in a cave to telescopes peering deep into the edge of the cosmos, and thus what lies beyond the observable universe, whatever it may be, is always present in every gaze toward the stars. Not as a destination, but as a depth. A depth that transforms every galaxy on a telescope screen from mere object to invitation. An invitation that beyond the light may lie realities that will forever change the way we understand the universe and ourselves. When looking up at the night sky, there is a tendency to think one is seeing the world. But that is only true if the world is truly singular. What happens if what we call the universe is merely an isolated region, a small bubble within an ocean of countless other realities? And if there are other universes different in physical laws, fundamental constants, even in the structure of space and time itself, does that mean everything we know about this world is only one version among an infinity of possibilities coexisting at once? The idea of the multiverse is no longer a product of science fiction. It has gradually become one of the most serious theoretical frameworks physicists consider when trying to decode the remaining paradoxes of cosmology, and the reason does not come from imagination, but from the equations themselves. When the model of cosmic inflation was built to explain the ultra-rapid expansion just after the Big Bang, those equations implied that the process does not stop at one place. Instead, it continues indefinitely, creating countless new regions of space, each like an independent universe with its own history, structure, and laws. This is the model known as eternal inflation. In this picture, our universe is merely a bubble in a constantly roiling sea. Each time a bubble forms, the physical constants can differ, like each soap bubble carrying its own colour. Some might have no stars, some might have no stable atoms, some perhaps could be identical to our universe, or even contain other versions of each of us living inside them. Another possibility comes from quantum mechanics. According to the many worlds interpretation, each time a choice occurs, each time a particle branches in measurement, the universe splits. One branch where the electron passes through the left slit, another where it passes through the right. One branch where Schrödinger's cat is alive, another where it is dead. And with every human action, every decision, whether drinking coffee or making a phone call, the universe divides. Every possibility, instead of being eliminated, is realized in its own branch. In that vision, there are countless copies of each person living in countless parallel universes. One version may be living an entirely different life based on a single decision diverging in the past. These possibilities cannot interact, cannot interfere, but they exist as layers of parallel reality drifting in a vast Hilbert space that only quantum mechanics can describe. Going further, string theory, an attempt to unify all forces of nature, leads to a vast space of possibilities called the landscape of vacua. There could be as many as 10 to the power of 500 possible universes in that framework, each one a different solution to the superstring field equations with different ways of compactifying extra dimensions. These universes may have different numbers of dimensions, different structures, and in many cases be entirely inhospitable to life. And this is when the question shifts from, does the multiverse exist? To why does our universe appear to be so perfectly suited for life? This is called the fine-tuning problem, the delicate adjustment of physical constants. If gravity were even slightly stronger, the universe might collapse before stars could form. If the electron's charge differed by a billionth, atoms might be unstable. Our universe lies in a very narrow range where everything is just right for life to arise. The multiverse offers an answer. Not that the universe was designed, but that there are countless universes and we are in one that permits observers to exist. Not because the universe is tuned, but because only in such a universe can the question even be asked. Like a lottery winner asking, "Why am I so lucky?" forgetting that millions who did not win have nothing to say at all. Yet a major issue remains. The multiverse cannot be tested. If other universes never interact with us, leave no trace in gravitational waves, cast no shadow in the cosmic background, then are they part of science? Or are they a slip of reasoning where logic is extended beyond what can be observed? This is not merely a question of physics, but of philosophy. Where does the boundary of a scientific theory lie? Some physicists argue that if a theory such as inflation or string theory predicts the multiverse inevitably, then accepting that consequence is reasonable even if we cannot see the other universes. just as we do not have to travel to Earth's core to believe it contains iron if all surrounding observations point to it. Nevertheless, whether it exists or not, the notion of the multiverse has expanded human thought. It forces us to rethink reality not as a single space, but as layers of reality that can stack, branch, or run parallel. It turns the universe from a single scenario into an ensemble of infinite possibilities. And if reality is not singular, then the questions of meaning, of the place of consciousness, and of existence itself become deeper than ever. The multiverse in this sense is not just a physical theory, but a challenge to intellectual humility. It reminds us that this universe, no matter how vast, may be only a drop in an ocean of what can be. And in that ocean, every gaze toward the sky from any universe is a whisper of awareness, trying to find its way back to the whole. Not to control, but to understand. Not to conquer, but to merge. For if reality is not singular, then understanding itself must widen beyond the limits of perception, reaching into the boundless frontier of all that may exist. When the full picture unfolds, when the layers of structure, from planets, stars, galaxies, superclusters to multiverses, stretch out like rolled maps unfurling in the darkness of the cosmos, what remains is not data. It is a feeling, a strange and contemplative sensation that after all that has been seen and interpreted, what echoes back is not the noise of information, but the silence of meaning. Earth, a tiny planet drifting in the dark sea. The Sun, an ordinary star among 100 billion others. The Milky Way, just a star city within the endless network of galaxy clusters. And the observable universe perhaps just a fragment among countless unknown universes. On the axis of scale, humanity doesn't even leave a dot. Yet within that smallness lies a paradox. Because if the universe is silent, how can a being exist that knows how to listen? If everything is merely drifting matter in space, how could a mind arise capable of observing that very drift? And if time is a cold, unfeeling flow, how could there be a consciousness that questions beginnings and endings? There is no data in physics that necessitates the existence of consciousness. No equation in quantum mechanics demands an observer. Yet, this world has one, a being that knows it exists, that looks to the sky and wonders, what is all this? In the silence between the stars, human consciousness rises like a fragile echo. Not because it breaks the silence, but because it listens. The universe doesn't need to be aware of itself to continue existing. But the presence of someone who looks up and feels awe, that is what allows the universe to be known. And to be known is no simple act. It is the moment when matter becomes awareness. When carbon, hydrogen, and water, through a journey of billions of years, finally come to know they are part of stars, of dust, of cosmic structure, and of life. The wonder lies there, not in the immensity of numbers, but in the ability to recognize smallness without despair. On the contrary, within that smallness, humans discover an inner space without limits, a space in which an individual with a brain weighing less than 1.5 kilograms can conceive of a universe over 90 billion light-years wide. Can understand the fundamental forces, simulate star formation, and imagine universes never seen. No one has ever laid eyes on the entire universe, but we understand it, because within us exists a reflective model, a kind of inner light requiring no eyes, only thought. This shows us the universe is not made of matter alone, but is animated by meaning. A meaning that does not come from outside, but is born from the very act of seeing. When a being looks to the sky and feels small, that is a sign of intelligence. When that being continues searching despite perhaps never finding all the answers, that is a manifestation of faith. And when it accepts the vastness not as something to be devoured, but as something to be a part of, that is the mark of cognitive maturity. The miracle is not in conquering the universe, but in the fact that the universe allows us to exist within it for a fleeting moment in time on a small patch of space with a consciousness deep enough to ask, who am I, and why does all this exist? This is not the conclusion of a chain of facts. This is the pause between questions, a space opened for contemplation. No more numbers are needed. No further theories required, just a moment to realize we have seen, we have understood to some extent, and we have learned to be silent before what remains unknowable. Because if there is one thing that makes humans worthy of being called observers, it is not that they have explained everything. It is that even in ignorance they keep going, they keep asking, they keep pointing their telescopes toward the dark, and they keep dreaming. Smallness, silence, and wonder are not mutually exclusive. They uphold one another. Because we are small, we listen. Because it is silent, we see. And because we cannot grasp everything, we learn to treasure what exists. And perhaps if one day another intelligence in a far-off corner of another universe looks up and wonders the same thing, then that moment, even if it never intersects with ours, would be the greatest empathy ever known. Because in infinite space there exist minds that love its infinity, not to possess it, but to become one with it. And that alone is enough to make the universe, however vast, feel closer than a breath.